So welcome to Everyday Mathematics. Here at Everyday Mathematics, as we always say, we do enjoy solving the harder problems, but above all, we also see and appreciate the beauty in the simpler problem. So today's problem is a problem that came from one of our fans at repeater.math 2024. It's indeed a fun problem, and it is the indefinite integral of x to the power 2024 over 1 plus x squared to the power 2023, right? So this is a very interesting problem. Before I jump into the solution, I'd like to thank our subscriber. Thank you so much for your support. The support really would does go a long way in giving us that extra visibility that we need, and it's growing. We are so pumped about it. For our first-time visitors here, what we do at Everyday Mathematics is we go around and about and look for these seemingly interesting problems. We try and solve them, and then we come back with solutions to them and share with you. To those of us who are here for the second or third or fourth time and haven't subscribed, we do really encourage you to consider subscribing to our channel. Your support would really mean a lot to us. That support will give us that extra visibility that we need to grow our channel. So with this problem, the key thing here is for me, personally, I would be inclined to use integration by parts. And so this problem essentially is the same as the integral of x to the power 2023, right, times x over 1 over x squared 23, sorry, dx, right? And since the derivative of 1 over 1 plus x to the power 22 is equals to 2x times 2022, and this is negative 1 plus x to the power 2023. And the product of this by 2022 and 2 is 4044. So essentially, this part here is the same as the derivative of negative 1 over 4044, because we want to cancel this constant here. And this is 44, sorry. And this negative here cancels this negative times 1 over 1 plus x squared 2022. Okay, so what we can do now is, okay, say that this, let me just erase this so that we can see whatever we're trying to do here. So we've said now that this part here is the same as whatever is in the derivative under derivative sign, and then this part is this part. So we can use now integration by parts, where if we have the integral of capital U d capital V that is equal to U V minus V du, right? And so our UV is this V here, and then the U is here, is what we have here. And then du is the derivative of now x to the power 23, which is 2 to the minus 3 times x to the power 22. So this is the integral of v du. And this minus sign here interacts with this minus sign, so we have a positive sign there. And so we can repeat this process again using integration by parts, where now we have x to the power 21, and the same process we have here is now what we have for the x over 1 plus x squared to the power 22, and this is the v part. And we continue repeating that process. We keep going. And so this part here remains. And then now here we have this constant here, and since this is v and this is u, so uv is the constant times this x to the power 21 over x1 plus x squared to the power 21. So, and we keep continuing with that, and we keep going, going and going. And then we'll have to notice one thing. There's one thing that we'll end up noticing, right? So we have 2000 x to the power 23, x to the power 2021 here on the numerator, 2019. So the numerator is reducing in steps of 2, and the denominator here is reducing in steps of 1, 2022, 2021, 2020, and so on and so on. So at some point, what happens is that the denominator will vanish, and we will have only, the numerator will vanish and we'll have only the denominator. And at that point, what can be determined if you look very carefully is when 1 plus x squared, the denominator is to the power 1010, right? And then from there now, we do have to now change our strategy as we go forward. So you see, we've now said, okay, the pattern continues. So the first is negative 1 over 4044 times x to the power 23 over 1 plus x squared, the power 22, minus 2023 over 4044 times 4042, x to the power 21 over 1 plus x squared to the power 2021, minus 2023 times 2021 over 4044 times 4042, 4044 times x to the power 19 over 1 plus x squared to the power 20, minus, and so on until we hit this point where we only now have the integral of 1 over 1 plus x squared to the power 1010. So the strategy there shifts, and let's focus on that, this part here. How do we integrate an integral? How do we integrate an integrand that consists of 1 over 1 plus x squared to the power n? So let's call n as the integral of 1 over 1 plus x squared to the power n, which is equals to, this is just the same as we've just played with things here. We've put this x squared and this x squared would cancel, you're left with 1. But essentially what you see here, this now divides the denominator, and we have n minus 1 here. So we have in minus 1 minus the integral of x times x over 1 plus x squared. This x squared is same as x times x, right? And so using integration by parts, as we can see, this here is inside the derivative sign here would have, in other words, 1 plus, x over 1 plus x squared is the same as the derivative of 1 over 2 times n minus 1. minus, times 1 over 1 plus x squared to the power n minus 1, right? And so we continue, and we show that now using integration by parts, this is v and this is capital U, so uv is 1 over n minus 1 times x over 1 plus x squared to the power n minus 1, minus minus, because of this minus, 1 over 2, 2 times n minus 1, times the integral of 1 over 1 plus x squared minus 1. So as you can see here, this is the same as I n minus 1. So we now have I n minus I n is equals to I n minus 1 over 2 times n minus 1 times x over 1 plus x squared to the power n minus 1 plus 1 over 2 times n minus 1 power times n minus 1. So this and this can be brought together. And so we have 1 minus 1 over 2 times n minus 1, I n minus 1 minus 1 over 2 times n minus 1, x plus 1 x plus 1 plus x squared to the power n minus 1. And so this is now 2n minus 3 over 2 times n minus 1 times I n minus 1 minus 1 over 2 times n minus 1 times x over 1 plus x squared to the power n minus 1 is equals to I n, right? And so the important thing to note here is that we can continue with this recursive nature of our equation. We can use the same process to find I n minus 1. So we can keep going and going, and then we get a pattern. We get a pattern here where we see that if I n minus 1 is our focus, we can replace I n minus 1 with the relationship that corresponds with I n minus 2, right? So we have this bracket, and so now we have I n minus 1 expressed in form of I n minus 2, right? And so as we keep on working along, we see that there is a pattern, right? There is a pattern in which I n can be related to I1. So obviously there's I n minus 2, and then we can work for I n minus 3, and then we just keep going and going, and you realize that we can now go like that because in the numerator we have 1 over 2 times n minus 1 times x over 1 plus x squared the power n minus 1 minus 2n minus 3 over 2 squared n minus 1 times n minus 2 times x over 1 plus x squared n minus 2. So as you can see, the denominators here, the multiplication continues. So here we have 2 times n minus 1. Here we have 2 squared n minus 1 times n minus 2. Then we have 2 to the power 3 n minus 1 times n minus 2 times n minus 3. And then the numerator is we have 1, 2n minus 3, and then 2n minus 3 times n minus 5. So there is these are kind of odd numbers here. And so we see that we can go all the way until we hit 1, and that's when we have I1. And I1 is simply the integral of 1 over 1 plus x squared, not the power 1, which is the integral of 1 over 1 plus x squared is a tangent of x plus c. So essentially now, if our 1010 is shown as follows, then our original integral of x to the power 2024 over 1 plus x squared to the power 2023 is equals to a negative of 1 over 4044 times x to the power 723 over 1 plus x squared 722 minus 2003 over 4044 times 4042 times x to the power 721 over 1 plus x squared to the power 721 minus 2023 times 721 over 4044 times 4042 times 4040 times x to the power 719 over 1 plus x squared to the power 2020, and so on until we hit 2023 times 2021, 2019, all the way to 1 over 4044 times 4042 times 4040 times 4038, all the way to 720 times I10, where I to the I1010. And we see that I1010 is shown here. So we do have our answer. We could express it in a way that is compact. I wouldn't like to really spend a lot of time on that. But you can see that by pen and paper, you can really solve this problem. Um, it's not within reach, it's accessible. Um, I hope you've learned how to do or to go about solving this problem. If you have any questions, please feel free to reach out to us. And as I said, this problem came to us from our very special fan, follower of our channel, who asked us, hey, could you solve this problem for me? And I was like, sure. I initially wanted to keep it easy. I thought maybe there were limits and that would simplify the solution quite. But I say no, there are no limits. And so at retheta.map 2024, I hope this has answered your question. I would be glad to discuss with you further this problem. But other than that, it was an absolute pleasure. Thank you so much for sharing this problem with us and keep them coming. Ta-da! Thank you. Tutalu ala proshin kwa.